Welcome everyone to this second session of Talking with Titans, jointly by Aquaculture Nutritionist Network and Jeffo Nutrition Inc. As you know, Aquaculture Nutritionist Network was created in 2011 by a group of enthusiastic aquaculture nutritionists as a LinkedIn group, which has grown to close to 1,800 members today. And Jeffo Nutrition Inc., a Canadian company, is a global leader for non-medicated feed additives, started in 1982 by Mr. Jean Fontaine, an agriculturist by training, with a mission to help the people who feed the world by making their life easier. So last month, in partnership with Jeffo, we organized the webinar series Talking with Titans with Dr. Albert Tacon, who is also here with us today. As you all know, Dr. Tacon has made impressions on hundreds of lives, if not thousands, worldwide, directly or indirectly, encouraging people to learn about aquatic plants and animals, farming, and their feeding and nutrition. I would say at least a major impact on my life as well. People all over the world see him as a big beacon while dedicating themselves for the improvement of aquaculture and aquaculture technology, and in turn, improving the lives of the people at the fringe. And now I would like to introduce Professor Dominque Bureau, who hail from Guelph, University of Guelph. And I would like to share some of my personal experience. He's the person who changed my life as well at the end. So I was a drowning ship, I would say, almost drowning ship, right? Couldn't find my way out. And I think he offered me something which changed and pushed me to learn nutrition as well. So I would like to invite Dr. Bureau to take a few minutes on his journey from a small town called Sherbrooke in Quebec of Canada to be one of the global leaders in aquaculture nutrition. Dr. Bureau, please.
Thank you, Kabir. It's a pleasure to be here. So my journey started in a small town, Quebec, Sherbrooke, Quebec. And when it was time to go to university, I was looking for something related to life science and something related to engineering or life science. And I came upon this program called bioagronomy, which was a mixture of agriculture and biology and things. So you became an agronomist or agriculturalist. And it was really suited to me because it was applied life science and related to food production. So I love that. I went to Laval University to study this in this program in the beautiful city of Quebec City. Fell in love with the city, had a fantastic time there. But after a couple of years, I was working, taking classes. I wanted to see the world. That was one of my interests. So I went on an exchange program, and the first part was in British Columbia near Vancouver. And I worked on a dairy farm for 3 months. And we were paired with a group of youth from Thailand. And then we went for 3 months in Thailand, in the northeastern Thailand, and lived in a rice farming village and cassava farming village, and taught English and basically was involved in the farming. And I really loved the experience. I love working on a dairy farm, and I love living in a small village in Thailand. I came back really motivated, and I completed my undergraduate degree. I really pushed, and I really wanted to push further my studies. I went to do a master's degree back in Thailand, and I was interested in aquaculture, and I'll just explain in a few minutes why. And then I became passionate about feed formulation and nutrition because it was the main question I had during my degree. And I asked my advisor, who's the best in the world in feed formulation? Oh, he told me it's a guy called Young Cho at the University of Guelph in Canada. I say, I'm ready to go to UK or US to study. And he said, no, just 700 or 800 kilometers driving down the highway and you'll find him. He's very special, but he's the best in the world in that field. So I went to meet him, and the rest is history. I just joined the lab, got along really well with him. I was basically his only student for about 7 or 8 years. And when he retired, I took over his job. So what a best things. And so I had everything set up for me with the lab facilities, the techniques, the infrastructure, even the funding were there. So I was the luckiest guy on earth. I'm the luckiest guy on earth. So I tried to make the most of this opportunity, this great opportunity that was presented to me at that time and still today. Thank you.
Thank you, Dr. Bureau. Now I would like to introduce the key person of this seminar series, right? And she is Annie Saint-Pierre from Jeffo Nutrition Inc. Marketing Department. And without her, with Jeffo's help is there, and then he is the key to in the background and in the front to help us. And let her introduce herself, and she will talk some of the housekeeping that for this meeting. Okay, Annie, floor is yours.
Well, thank you, Kabir. So I am the one working in the back end to organize this webinar. So few housekeeping for you tonight, easy stuff. So tonight's presentation is going to last about 30 minutes. We're going to take the Q&A. We're going to allow the Q&A for about 45 minutes after the presentation. You have a chat box at the bottom of your dashboard. So during and after the presentation, you are more than welcome to leave your comments and your question there. The question will be answered by Dr. Bureau as well as Dr. Tacon. Note that we left a copy of tonight's presentation in the document file, and we will also share the video after this session with all the registrants. So that's about that. So enjoy the presentation.
Thank you, Annie. So we are going to start. We just 6 minutes past 9, so we have, I think, ample time today for the presentation and discussion. So I will let Dr. Bureau to take the floor. There is no floor, but we are on computer now, so we have individual floors. So I will take Dr. Bureau to take up his floor just to the presentation. Thank you, and it will be mostly
I can share my screen.
Go ahead.
All right, I'll try to share my screen. Oops.
Just a second, I'm going to help you.
Right.
No, we have a little problem here. Second. There you go. You should be.
All right.
Now.
Yeah. I'm just seeing. I'm just trying. Start sharing your screen. All right. I have to ask, you're seeing my screen?
Yes, we can see your screen.
Okay, perfect. So Kabir asked me to talk about data in aquaculture and aquaculture nutrition and some of the challenge and opportunity based on my experience dealing with data in both the field of aquaculture nutrition and aquaculture. Like I mentioned, my interest in aquaculture developed when I went on an exchange program in Thailand. I lived in a small village, rice farming village, and I was amazed by the fact that there was fish present in the field, the flooded rice field, inundated rice paddy field. And I thought to say, well, we're growing the rice, why can't we grow the fish? So aquaculture really, my interest in aquaculture really spawned from this integration of agriculture and aquaculture. But then I realized that aquaculture is a field by itself and deserve, so you don't need to grow the fish with another species or another production system. So I started focusing on that thing. I became interested in nutrition and I started doing research with Clarias garipinus, the African catfish, using crop residue, so making diet containing crop residue in the diet of these fish. And my experimental setup looks terrible and all this, but everybody laughs at it. But I made it from scratch with the help of a few undergraduate students and paid it all by myself and this, and I paid it for many, many years after that. So I'm really proud of the work that I was able to do on a dime when I was 24 years old. This first experience opened up my interest in the world, and I started traveling the world. Basically, joined the University of Guelph and became a researcher, a grad student, and then researcher and a professor there, and maintained a dynamic research activity. But all throughout the years, I've been having many international activities in Southeast Asia, again, Thailand, but also Indonesia for many years, the Philippines, Vietnam, China, Panama, Chile, and Brazil, and France, and etc., all these places. And all these places, I didn't have any lab, but I was involved with people doing research and gathering data, and I got lots of insights on the use of data and advising people on to do this. I was fortunate, extremely fortunate, to be invited to be part of the Committee on the Nutrient Requirements of Fish and Shrimp. In 2009, we published our findings in 2011. We reviewed thousands of papers, literally over a 16-month period or something like this. We created what I think is a very good document, an imperfect document, but it was the best effort by the committee on a very short notice. And that represented a lot of data compilation. This is not simply a literature review. It's really, we gather the data, we analyze the data, at least on the amino acids and the energy and some of the other aspects. We really gathered the data, compiled the data, and did the best out of the available data. And that's kind of been a recurring theme in my career, is gathering data, compiling data, analyzing data, interpreting, and then turning this data into something useful, tools or models or recommendation or something like this, has been really the motto, or basically what has transected my entire career. And you can see some example of this. The most recent effort of this is the International Aquaculture Feed Formulation, which used to be called the Asian Aquaculture Feed Formulation Database. And it's a database, free database, easy to access. You can download all the data you want from it. And it's nutritional specification for 30 aquaculture species and chemical composition for over 500 ingredients, with 249 parameters for these ingredients. So a big effort, and that meant gathering data, gathering tons and tons of data, vetting the data, auditing the data, right, and turning it into something that feed manufacturers or whoever else is interested in this kind of data could use. And then I was involved in a number of startup companies, and they didn't all survive, but this one, created in 2017, is growing and thriving. It's called Hudayakwa. And again, it's very much an effort to compile, gather data, audit data, analyze, etc., and develop tools for aquaculture producer, but also now for aquaculture feed manufacturer and aquaculture feed ingredient provider, feed additive companies, and other people involved in the business of aquaculture. When we talk about data or in aquaculture and nutrition, I read a lot of press article or technical article on this, and it seems that the general mindset is the more data that we have, the better. And everybody loves data. Oh yeah, we collect data, we do this and all this. And it seems that big data is the way to go. So more data and all this. And it seems like fancy technique like artificial intelligence, machine learning, big data analytics, basically all these techniques will basically solve all the problem that the industry ever has and encountered. Having worked with lots of data, I can say that yes, lots of data is collected, but actually very little is shared, and even less is adequately valorized and made use of by the people. And a lot of the data is often biased or contains significant errors in data. And in many cases, they're just guesstimates, or just numbers. So people will put down a number and say, yeah, that's a number, but they actually just made it up. So this is a very common issue in aquaculture. Now, data is only meaningful if it's transformed into information, and then information is transformed into knowledge and wisdom, as the common saying says. And there's many ways to transform this data into knowledge, right, into information and knowledge. So there's different ways of analyzing and interpreting this data and transforming or making these data points usable. Now, we always talk about the potential of big data and machine learning and etc. to help you find out the truth, but we've been involved, or humanity has been involved for at least over 500 years in modern chemistry, biology, nutrition, and mathematics. And I feel that this is providing a more solid starting point than just trusting a machine to say, well, tell me what is the truth. Well, actually, we know how things are working, so we should be starting with what we know, what we understand, and then complement this understanding with data, and not the other way around. So the data is not always a starting point. It's an important step in this, but it's not always the starting point. One issue that we see with data is, first of all, it says, yeah, there's a quantity, and the quantity is there. However, the accessibility of these data and the sharing of these data is not always available. Second, I mentioned some data is erroneous, some biased, some made up. So the reliability and relevance of the data is not always all is. Then the analysis and interpretation of the data is a complex issue. And then transforming this information or data information into knowledge, right, is what is important. And for me, from a practitioner perspective, practical perspective, data and knowledge is only useful if you can translate it into something people can use, either a tool, right, a formulation software, or a recommendation, a level of nutrients or feeding recommendation, or something like this. So data and information itself is nice, but being able to use that information is more important in the end. Now, we're fortunate in the field of aquaculture. The field of aquaculture nutrition is extremely dynamic. It's a very dynamic field. There's literally hundreds of research groups working on aquaculture nutrition. You go to conference in China, there's very often 1,500 people, right, all in one field on fish nutrition or aquaculture nutrition. You'll have 1,500 people coming from dozens and dozens of different research centers. And you go around the different countries around the world, the hundreds of countries around the world, and you always find a fish nutrition lab or an aquaculture lab. There's a real interest in aquaculture and aquaculture nutrition, and it's well supported by government. For all we complain about funding level, actually it's a field that is pretty well supported by different level of government. And there's tons of research on soybean, on animal proteins, fats, and I'm listing different efforts that I was involved in. I got a contract one time with my lab to review all the information on soybean product, and then one on to review animal proteins and fat, and then one to look at fish meal and fish oil replacement. And we always find literally hundreds of paper. And this is only the tip of the iceberg, because I know that many players in the aqua feed industry have very dynamic research and development program in their own facilities, and they don't publish, but they generate tons of data. So we do have a lot of data to work with. That's not a question, right? The problem is how accessible and truly valorized this information is. Yes, data are collected and they may be transformed and analyzed, but it's very often what I call a data pileup. It ends up being stacked up in a computer file or file cabinet, and people are pretty proud to say, oh, I've got lots of data, I got lots of paper, I got lots of this. Well, it's like having a big library, but you never read a book in your library. Yeah, you can have a beautiful library, but you didn't make anything out of it. And what is important, in my opinion, is to transform this data into knowledge and wisdom, right? So that knowledge pyramid where you transform data into information, knowledge, and wisdom. And that's a lot more valuable than having your data sit in a file cabinet or in a file on your computer. The problem is that a major problem is the fact that the quality of the information available is not consistent. When I was a member of the NRC committee, I was in charge of reviewing essential amino acid requirements of fish, and I hired this postdoc called Guillaume Saz. And I was very proud. The first day Guillaume joined the lab, the first week he joined the lab, I walked over to his desk with a big, huge file of paper. I said, here's your work cut out for you. I got 286 paper for you, or whatever number of papers I gave it to him. And he came back to me a few days later. He says, well, of the 286 papers, there's only 249 that are relevant. And then he went further and looked into detail to paper. He says, well, really, there's only 109 papers suitable for what you want me to do, because there's information that's missing, because there's insufficient graded level of amino acids, or there was poor growth performance in that studies. And this is for 22 species, for 10 essential amino acids, 2 non-semi-essential amino acids. So that means, right, if you're lucky if you have 1 paper per study per nutrient. So it's a real dilution of effort, because we have too many species that we're studying and many nutrients to worry about. So yes, we have a lot of data. When the data is shared, this data is not always of equal quality, so you cannot fully valorize this information because of this problem of quality. Even when you have quite a bit of data on one nutrient and one species, like lysine for rainbow trout, and you plot the data, and you can plot it different ways, you can transform different ways, and I tried 10 different ways to express it, and this is the best we could get. We calculated a thermal unit growth coefficient and a lysine level. Fish were relatively of the same size, relatively speaking. And this is what you get. Yeah, the response is similar, but I basically challenge you to find the nutrient requirement level. I think it's around 2.4, 2.5, and somebody else may look at it and say, no, it's around 2 or 2.1, right? So even if you have a lot of data, your interpretation of the data is not simple, and different people will have a different opinion. Even if you have one data set and you're very systematic, the way you analyze your data will possibly results in different estimates of requirement. Using a broken line analysis model versus a nutritional kinetic model versus a 4-parameter model, we arrived to very different estimates of requirement. Work by Pedro and Canasao back in the early 2000s to show this. Additional work we did in this field, so if we base the requirement based on weight gain versus requirement based on protein deposition and use different mathematical model to fit the data, we arrived to 8 different estimates of requirements, just 2 parameters, 4 mathematical model, 8 very different estimates of requirement, going from 2.11 to 3.15. So a 50% difference in the estimates of the requirement, which is kind of things. So the challenge in the analysis, so you can have data, you can have lots of data, you can have very good quality data, because I feel this is one experiment that we did well. But depending on how you analyze this data, you'll arrive with different information and different knowledge or different interpretation of the results. Now, the solution, in my opinion, is to go one step further and use more elaborate approach to analyze your data, interpret your data, and complement your data, your understanding. And this is where data and knowledge-driven models are becoming more, these are becoming more important. And then you can expand this and say, well, so what we call hybrid empirical, mechanistic, and artificial intelligence driven model are really taking over the field. And there's a number of very recent paper on this that are really interesting to read. And I'll show you an example of some of the work that we've done in the same vein, not exactly, but doesn't involve machine learning yet, but actually it's very much in the same vein. And I presented these results so many times, probably two or three, 4 or 5 dozens of times. I stopped counting. And it was work by Kathleen Watt. I think it's the best work that my lab has done. Like when I think about the work we've done, this is the one that strikes my imagination the most. So Kathleen's review many papers on digestibility of phosphorus in rainbow trout, 22 studies that she found were trustworthy. She did weed out a number of studies and found 137 treatments that were reliable. And we look at the level of phosphorus level and digestibility, and we found that the data were going in different directions. Some studies were showing, well, increasing level of phosphorus, decrease of digestibility of phosphorus. Some other paper found, no, there's no effect. But then there's no meaningful range in, meaningful trends in the range that we formulating feed to, in terms of digestible phosphorus level. So it's very difficult to make sense of that information without a proper system. And that's what we did. We developed a system in order to understand information. The phosphorus in feed is not just phosphorus, it's associated, It's a phosphate, and it's associated with different kinds of molecules. From bones, the phosphorus contained in bone, in adroxyapatite, in the phosphorus contained in phospholipids and nucleic acids, and etc. The phosphorus associated with phytic acid, the phosphorus that is supplemented as monobasic phosphorus supplements or dibasic phosphorus supplements. And then there's the impact of phytase enzymes. So we classify the different forms of phosphorus, the different concentration of these different forms of phosphorus in the feed. And this information is made available in the IFFD.com website. So we've added these different forms of phosphorus. So you can go back and replicate our work if you want. And using a simple multiple regression approach, very simple statistics, Just the first year statistics approach, we were able to estimate the digestibility of the different forms of phosphorus, and moreover, establish basically interaction between different forms of phosphorus. And we're able to develop equation, one for rainbow trout, one for cyprinids, one for tilapia, which actually generate very good, reliable estimates of digestible phosphorus of feed made with a wide variety of ingredients. And I tested it in the field with feed companies, and it worked out really, really well with the different species. So this is an example, turning data, crude data, right? Transforming it into information using a good system, and then transforming it into knowledge and wisdom, right? By creating a tool out of this that anybody can use, right? Or anybody wants to use it can use. Another example of this work, again, done with Kathleen Hua, my graduate students and postdoc for many years. We got a contract with the United Soybean Board, US Chekhov program funded organization that funds research. And he asked us to do a meta-analysis on fish meal replacement by plant protein ingredient. And we looked at the data and the research and say, well, everybody's kind of looking at the statistics or doing an experiment. They have dependent variable, independent variable, and dependent variable. They run stats and arrive to a conclusion. So you replace fish meal with a plant protein ingredient, so you increase the level of a certain plant protein, soybean meal in a diet. And then quite often in papers, you'll have no effect, and then you have a significant reduction in performance. And that's nice, you know, okay, so my increasing level of this more than 30% or something results in significant depression of the growth performance. But you don't know why the performance was decreased, right? You say, well, the fish perform less well. Well, why did they perform less well? Were the nutrients becoming, some nutrients were becoming deficient? Or was there other limitation, an anti-nutritional factor, an effect of feed intake, etc.? So you can say there's an effect, but you cannot say what the effect is related to. So we developed an approach that says, well, we need to upgrade the data in the literature. So we cannot just simply live with the raw data. We have to transform them. We have to look at the composition of the feed, look at whether the feed are nutritionally adequate, so contrast the levels of nutrients in the feed versus required level. We also computed or adjusted the level of dependent variable, the growth rate, the feed efficiency, nutrient deposition, etc. We plugged them in our equation, so we, regardless of the size of the animal we had, the water temperature, all this, we're able to standardize, make things really quite standardized. And then we had upgraded standardized independent variable and upgrade standardized dependent variable, which we could use in our meta-analyses. But we also developed a growth and nutrient utilization model that allows us to predict the performance of the animal based on the composition of feed that they were being fed, the feed intake that they had, and then predict performance. So this is the model that we developed. So we worked many years on this to develop a more advanced model, and we went back actually on the use of bioenergetics. Even though there's limitation to bioenergetics, it worked pretty well. But we incorporated elements of nutrient flow in it. So our understanding of nutrient utilization, we put this understanding into the model, but was rational and made sense. Using this approach, we're able to make a prediction how the animal should respond. And then you look at the actual response of the animal and you see whether your prediction was reliable or not. If your animal performed less well than what you predicted, well, you say, well, I understand part of it, but I don't understand part of it. So therefore, you understand your gap in knowledge, what you don't understand. If the animal performs better than what you predict, then you realize, well, my model is overplaying the situation, is overestimating nutrient requirements or something like this. So therefore, my model is no good. So this interplay, this game that you play with the data and the model, helps you get to the truth, get to you to the reality. The data helps you, the model helps you interpret the data, but also the data helps you determine whether your model, what your understanding is, and whether it's suitable or not. So we ran with soy and lupin and canola protein concentrate, and we got pretty good results. But in many cases, the observed performance were better than what we were predicting using our model. And we realized to say, oh, actually, we think in this case, Kathleen at least thought that say maybe the NRC recommendation that we're using as determining the nutrient requirements maybe a little too strict. So the NRC committee, we went a little bit overboard in some of the recommendation for certain essential amino acids, for example. So therefore, it yield pretty good information saying, well, maybe the animal can make do with slightly less good diet or nutrient level than what we were expecting. That was really quite interesting. And we really only scratch the surface with this approach. Kathleen, Guillaume Saz, and I came up with this scheme. It says, well, we've been integrating information from published research studies and upgrading them and developing all the studies in order to to compile them. So we developed this system called Akimasu, the Aquaculture Knowledge Integration and Modeling Analysis System. They say, well, we're going to make this available, this tool, online tool available. Researcher can upload the results of their research study, and then we'll have all the models that standardize the data and analyze this, and we'll have like an upgrade data set which we can share to anybody who wants it. They can download this big, huge data set, and then we can use the data set in our models, and we can develop interface, and we can develop tools for feed manufacturers, whoever wants to use it. We can publish, at that time, the Asian Aquaculture Feed Formulation database with some of the information, etc. And I went around and I presented this at the International Fish Nutrition Symposium in 2012. I presented a couple other times, different place. And really, I was surprised. I never got any feedback. The only feedback I got from a few people says, yeah, it's a good idea, but it's not my cup of tea. It's not something that interests me, so I'm not never going to use that. And somebody else told me, says, well, why would I share my data with you? And that made me think of that data pilot. I say, yeah, your data is so much more valuable sitting in your file cabinet than being shared around the world. So it seems that researchers still think that the file cabinet full with data is still more valuable than sharing this data. So we're not out of the bush yet in terms of sharing of data and making it transparent, but we're still trying. After this kind of failure of getting this effort together, work on the International Aquaculture Feed Formulation database, it says, well, maybe we should not just worry about the researcher, we should work with companies, feed companies and aquaculture companies, because they do have a data problem. I went to enough farms and enough feed mills to see that the data is compiled in a little book. And I like to joke sometimes, right? The sales guys in the field, they have a notebook, not a computer notebook, but a paper notebook and a pack of cigarettes. And they share the pack of cigarettes with the farmers, and they get the data back in their notebooks, and they go back to the factory, and the data is entered in a special spreadsheet, and etc. So there's basically a lack of data. So everybody's collecting data, but I don't think it's very efficient, and I don't think it's valorized efficiently. And from what I could see from data, there's lots of error. So I got data from Southeast Asia at what time, and so I got data from different farms, and I started looking at the data, and I highlighted like the red star says, well, the data on survival doesn't make any sense. The survival goes from 76 to 91 to 97 to 95 to 79. So what's happening, right? There's spontaneous generation, and then the animal dies or something. Well, no, it's just simply because the number was made up, was estimated using a certain way. Even the body weight estimates were kind of iffy sometimes, right? Because you may be overestimating the weight, underestimating the weight. The biomass estimates was as good as the number of shrimp that you think is in the pond and the biomass. So only the harvest biomass is reliable, and the feed consumed, because you're buying the feed and you're paying for the feed, is things, but there can also be some fraud. So I realized data from aquaculture operation are not always that useful, and they need to be vetted. They need to be audited in order to be used properly. Moreover, what I found is that the data from aquaculture operations, shrimp operations, for example, real data, are highly variable. I heard somebody tell me, say, oh, farmers, they know how big their shrimp are at day 65. They know there's going to be this weight. Well, look at the real data. They say, well, they can be, right? It goes from simple to double in terms of weight estimates on different farms, using the same feed, using the same PL source. So it's not true that the farmers know exactly how their shrimp is weighing or how the performance is going to go. It depends on the farm, depends on the season, depends on a whole bunch of factors, and performance are highly variable. And that has an importance. So we decided with Hudayakwa to develop a data entry system. So first have a data entry system, and then analyze the data and provide basically a second opinion to the farmers, how the fish, the shrimp are growing. They're growing according to normal. Is this sample weird or not? How much you should be feeding, etc. So help the farmers compile the data, but also help analyze and interpret the data and provide recommendation. What we realized is that that approach also is highly suitable for auditing farm data. For example, if you're reporting to a BAP or ASC or something like this. And what we found is very often the farm will overestimate the number of animals in a pond, in a cage, or whatever, and they would compute a feed intake or biological FCR, whatever, and they would always be wrong by 20, 30, or 40% in their estimates. When we recalculate using a proper estimates of the population, we get this. This may not matter at the farm level. Well, it can because it affects the feeding. But when you're reporting the data, if you're reporting the data wrong, you can create a scandal, you can create a problem. And this has happened in Chile. I know it has happened in China and different places where data coming from farms were basically not analyzed properly, and it was called data rigging, and it affected the industry. Started working before creating with Hudayakwa, with aquaculture operation in Canada. We collected data on rainbow trout fish culture operation, and it was really an interesting exercise in itself. Knowing how well your animals are growing, how well they're converting a feed, knowing the survival, the real survival, real mortality estimates, knowing which farm are doing better, which farm are doing less well, is very important. So by simply compiling and doing fairly simple statistics and computation on the data was extremely valuable to see how well the industry was doing. And we compare this to a standard or model farm that was operating in a different lake, but operated by researchers that were there all the time. And we saw that the farm was doing as well as the researcher. So that was good news for the industry, but we also saw that the performance was highly variable. However, when we look at feed efficiency or feed conversion ratio, then the story was really kind of strange because the data was highly variable. They say, yeah, it's fish raised in the environment, right? There's snowstorm, there's the weather temperature, the weather change, the wind and all this. You get different genetics, you get disease and all this. So it's normal to be variable. But is it normal to be that variable, right? For fish fed the same feed, the same genetics, right? And all this. So yeah, there can be some feed wastage and etc. So I was interested in knowing the source of this variability. Why was this variability? It was associated to environment, associated with something different. And by looking at the data of the farm, what we realized that the data of the farm was often very biased. We would estimate the growth trajectory of the fish, and we look at the farm data, and fish were bigger than what the harvest would be at the end. So this is impossible. So it was simply a sampling error. And when we compile the data from farm and look at it from our growth simulation, and we did the weight distribution of the fish, actually the farmers or the employees working on the farm were not lying. They were sampling real fish, but they were always sampling the bigger fish, especially when the fish were big. When the fish were less than 300 grams, there was not a problem. But when the fish were more than 500 grams, imagine catching a 500 rainbow trout, right? That is swimming away, 1,000 or 2,000 gram rainbow trout. It's a strong animal, and you're right, you only can go as far as with your hands or your arms as you can. So therefore, you catch the bigger, you entice the fish to come to feed, and you catch the bigger animal. So what happened is there's a bias in the data collected, and it affects the estimates of FCR. So the FCR becomes jumpy. But by knowing this, by recreating the growth trajectory of the animal, looking at feed use, then you can clean up the data, and then you can audit, properly analyze the data. Then you can actually see, yes, there's variability, but then this artificial or untrue variability is removed, and then you can start doing proper statistics and identifying realistic target. So we say, for example, we identify the top 98% performing things as the target FCR that we should be targeting, and it increased with size, and it's also varied with seasons a little bit and all this. So by simply processing your data, analyzing properly, you can clean up your data and you can extract more knowledge from these data. So the same thing with the shrimp data, the same thing can be done. The data can be cleaned up. We can clean up the nonsense. So in terms of survival, right? The survival jumps up and down, and it's nonsense. By using proper mathematics, we can actually estimate what was potentially the right number of animals, the real number of animals in this, and we develop algorithm to do this. The farmer assume a linear functions. Well, it may not be a linear function because smaller animals have a greater propensity to die than larger animals. They're more sensitive to predation, etc. So therefore, we clean up the data. So we have a better estimate of the number of animals, and then we can better analyze things like feed conversion ratio, right? Growth potential, or biomass, etc. Now, in terms of growth trajectory, we can do, right? We can apply different mathematics and all this. So when we have data, we see the performance is highly variable. We also see that we're flying blind for the first 30 days. People don't sample. So you don't really know what your size of the animal is for the first 30, 35 days, right? Because they're not sampled. So how big this? Well, you can make an assumption. A lot of people will use ADG to estimate the growth trajectory. But the shrimp is not growing in a linear fashion. At least maybe past 7 or 8 grams, the growth becomes linear, but before that, the growth is not linear, it's curvilinear. So you need at least 2 ADGs to calculate 2 ADGs in order to do this, or you need a better mathematical model. And that's what we did with Hudayakwa. We developed a Hudayakwa synthetic growth model, which is an evolution of the thermal unit growth coefficient. But we addressed the limitation of that model. We also introduced an effective temperature things that is depending on species, strain, and latitudes and stuff like that. So we developed a very robust growth index that can be applied across weight, across temperature, and across time interval. So the model seems to be getting this. Then we can use this model to benchmark performance, meaningfully benchmark performance. And with this synthetic growth index, we basically just need 1 numbers. So regardless of the time interval, the time span for which we have data, the number of data points, the initial and final weight of the shrimp, we're able to calculate a growth index and able to benchmark performance. This is the kind of culture that we need in aquaculture production in terms of user data. We need to be able to benchmark data. We need robust method that allows us to compare things across the wide variety of environment conditions that we have, size, temperature, etc. And it's very meaningful, right? You can think this real numbers, right? A farm getting or production lot getting a growth index of 2.17 versus one getting 320. Look at the difference. Look at the growth trajectory difference, right? So shrimp doesn't grow a certain way. They grow different way, depends. They have a growth potential, and often this growth potential is not fulfilled. So this is the same genetic, the same feed, etc., right? The performance can be significantly greater. So there is great advantage in understanding the growth potential of your animal and achieving that growth. And a simple growth model allows you to do this, not just for the end period when you're going to harvest, but at any point in time when you want it, to estimate feed requirements, oxygen requirements, need to change water, etc., etc. And that leads me to the ability to calculate feed. Here we contrast farm input, feed input data versus our prediction using our model. We call our own model calibrated using biologic, using the best data we had on shrimp, and we compare it to farm data, and the difference was tremendous. Farm was feeding 2 or 3 times more than we were recommending on the basis of biogenics principle. So then we say, well, yeah, but the farm has a muddy pond bottom and using the feed, and the shrimp is wasteful and there's leaching of nutrients. So we made a number of adjustments and we developed a new model for that specific farm. But look, the data from the farm is still significantly above the recommendation because it's human feeding the animal. So they say, well, the shrimp requires this. And they tend to overfeed the animal. And then they come to their senses, hey, we've been overfeeding. And then they go back to a normal level. And then they drift again and they're wasting a lot of money. You see the value of using the models to interpret the data. If you simply only have the farm data, the feed requirement, the feed use data, you couldn't make any sense out of it. But by having a benchmark, by having a model recommendation and adjusting this model to real condition, then you can actually make sense of the farm data and say, hey, maybe we can reduce feeding and improve FCR in this case because we're wasting a lot of feed. When you do this, right, you have to realize as a farm is reporting a live weight, you may be computing a live weight using your model. You have a feed serve, you have a model feed requirement, model derived feed requirement. So you have kind of 4 different ways of looking at the same data. But that's a richness in a way because you have 4 ways of viewing reality. So you're able, so what the farm is saying versus what the model is saying may be different. But then when you start mixing and matching different content, you say, oh, well, maybe this is the truth, what is really happening, right? Between what the farm is reporting and the theory, you find kind of the reality in between. Now, the other thing to talk about is that when you're dealing with shrimp farming and fish farming, it's a really complicated environment. And I see a lot not in the press and company websites says, well, let us put a sensor, put a machine, put this, trust our data, trust us with your data, and we're going to solve it for you, right? And it's often sell the dream of big data. Big data is going to solve it for you. It's going to figure out everything. Well, there's basic biological principle in there. There's logical principle. There's engineering, there's chemistry going on in there. So why let the computer solve all the chemistry for you when you understand the chemistry, when you understand the metabolism, when you can understand the nutrition, when you understand the limnology? So why not break down the process into the different things that we know, understand is happening, right? The shrimp is consuming feed, some feed is wasted, part of feed is digested. We can use our models and tools and all this to estimate this and at least, right, complete part of the puzzle, complete part of the picture. Then we can relate the water quality parameters, the production parameters to these process and start filling in the blank and then try to solve for the factors that are difficult to find, the assimilation of waste into natural food, for example, the resuspension of organic matter and etc., the mineralization, which is really quite hard to model. We can actually start, right, solving that mystery by a systematic approach. So you combine both data, right, and models or empirical, so both data-driven and knowledge-driven model to solve the solution, solve the problem in this case. We can use also this kind of platform to solve problems of feed companies. Feed companies want to know how well they're doing. So they're doing farm trials and customer trials and etc. on their own facilities or with customer. And they're looking at this and they're comparing itself. But you cannot cover all the farms. You cannot cover all the competitors. But by gathering data from the field, you're able to get a picture of how well you're doing compared to other feed competitor, right, across farm if you compile your data. You can collect data and you can see how well you're doing versus competitor. But what I found when we did this is actually many companies are producing feed that results in very equal, very similar performance. But actually it's the environment that affects the performance the most, at least the FCR, also the growth rate the most. So often people are stuck and say, oh, let's improve the feed, let's do this and let's do that. Actually, the feed may be good enough, but the growing condition may not be good enough. So actually, you may have an advantage not improving the quality of your feed, but investing effort in improving how well your feed is used, how is the water quality handled, how the farm is managed, how your clients are managing their crop. So it's not just always a question of nutrition, it's very often a question of management that makes or breaks the results in success of the farm. Now the feed is made of different ingredients, right? So you have a feed brand, but that feed is made of different ingredients to different nutritional specification. So you cannot stop there. You cannot simply look at farm performance and this is the feed label of the name of the feed. You have to look at what is inside the feed, not just the formulation, but the composition of the ingredient. So with Hudayakwa, we're developing what we call a raw material mapping tool for the feed manufacturer to input information about the raw material. We also have feed formulation tool, an economic evaluation tool, nutritional models that fits in there. And it ties in, it tags with the Aqua, the data compilation software. And then once we have this, we can also calculate sustainability index, fish in, fish out ratio, very objectively and robustly covered this. So basically my take-home message is data is extremely valuable, it's very important, but data alone is not enough. You need to interpret this data, and the user model systematic approach is key to verifying the quality of the data and making that data useful and transforming this information into usable knowledge, usable tool, practical tool is also extremely important in order to translate this effort into reality. So the company, I work at the University of Guelph, but I'm co-founder of Hudayakwa, and we have a number of clients. We're offering services. We're also supported by a number of organizations and have small investor that contribute a small way to certain ways into our investment, including Hatch, Ag Funder, to their Grow program in Singapore, BioEnterprise in Canada, NovaCorp, the AFT, the Mars, and the NRC IRAP program. I thank you very much for your attention and look forward to discussing with Albert, Dr. Kabir, and all of you. Thank you very much.
Thank you, Dr. Dominque Bureau, for your very informative and I would say resourceful presentation. I think Albert will join us soon if it's around. But we have a few questions already with us. First thing is we will try to divide this Q&A. We have about, I think, 40 minutes in our hand. So we'll try to divide quickly into 3 sections: nutritional side, nutritional research side, because data quality and everything always depends on the quality of research. As Dominique mentioned, Dr. Bureau mentioned that total of 700 plus published work, only 200 was usable. So the quality of research is a key, and when we cannot use the data, a lot of money, a lot of resources, a lot of brains are wasted. So we'll go about the first about the research. Basically, we have a few questions from the audience as well on research. So first question is garbage in, garbage out. I always hear this thing from both of you, that garbage in, and Albert talks about basura, right? So that's Spanish word for garbage, if you don't know. So data means nothing if the quality is not good, right? And as we said, only good quality research can give us good quality data. So how can you see like the importance of research, right? Yes, university in academia, we do a lot of research, and there are a lot of good research institute or departments around the world that are doing good quality research. But how much they're applied, right? And in terms of applicability, in terms of commercial application, right? Like there are various stakeholders, like feed millers, aquaculture operations, and they are always looking for good quality information to apply in their work, in their commercial entity. So how do you see the importance of good quality research in commercial aspects? So can we, who wants to go first? Albert?
Go ahead, Albert.
Okay, Albert.
Voice of wisdom.
Can you hear me?
Yes,
Okay.
Thank you.
No, really important. I mean, I would just like to support Dominique's presentation, and that is that at the end of the day, we're here to serve the farmer. And a feed company can sell feed to a farmer, but every pond, every cage, every tank, the result is different. And it's only really at the end when you know what your true survival is or what your true body weight that you actually can understand what happened. But very few feed companies and farmers actually analyze their data at the end of the season. And it's so important. And I think, Dom, what we want is also what we need as a tool that you can give to the farmer, which is not for the researcher so much, but more for them to better understand their results. Again, many feed companies have set up their own R&D, mainly because a lot of the information that they're looking for is not available. And you know, but no, I would just like to support what Dom's presentation, but that we have to analyze the data at the farm level for the farmer.
So Dom?
Yeah, so the quality of data is key. Obviously, the relevance of research is key also. So that's always promoted the dialogue between feed manufacturers and academic researcher. I wrote this many years ago in a column as my favorite part of the scientific meeting is the coffee break, because this is where I can go at the back of the room and talk to feed manufacturers and other scientists and have exchange about what is meaningful. So presenting the data is important, but getting the feedback and saying what is important, what do you think about this, what you thought about this presentation of this concept, and with people with different perspective is extremely important. So maintaining a dialogue is an important part in doing good research, in my opinion. Doing the good research that is relevant on the species that are relevant, the genetic that is relevant, using ingredients that are relevant as much as possible. But at the same time, researchers still have to keep their mind a little bit, because if you only listen to feed manufacturers and farmers, then sometimes you miss things. One example is range of nutrients, right? You say, oh, I'm not going to drop the lysine level too low because we're never going to drop that lysine level too low, but you need to know, you need to drop it low enough, the nutrient level low enough to know when you're having an impact, that you're reducing performance. So maybe it's not a commercial reality, that this lysine level or phosphorus level is not a commercial reality, But in your experimental design, you have to do it in order to know the limit of your animal, how they're responding. So the researcher still has to keep their own mind and do the research. But doing the research properly, sometimes it's just a matter of reporting the information properly, the dry matter content of your feed, making sure things are adding up. Again, right, something my mentor, my former advisor, Young Cho, would say, right, you go to a fish market, you buy 10 fish, you ask the fishmonger to cut the fish in 10, you go home, you get 11 head and 9 tails. Well, yeah, it's not a big problem, but you got cheated, right? 10% wrong, but you got cheated. It's illogical. You bought 10 fish, it should be 10 head and 10 tail, not 11 head and 9 tail. And that's the type of thing that you have to do with your data. Look at your data. Do my data add up and make sense? And it's very simple with a simple spreadsheet, simple calculation. You can see whether your dye composition makes sense, whether they're like what you expected. You increase the level of lysine. Are you finding that lysine? You're increasing the level of soybean meal, right? Is the protein the same, or right, the lipid the same? Is things does that up? Does it might line up with what you're expecting? Simple troubleshooting can go a long way in making sure that your data is good.
Right. If I may add to that, right? Sometimes, sorry, Albert, go ahead. I will add later.
No, I was just gonna add that. I mean, of the importance of people sharing data and the fact that it's only at coffee break that people really open up sometimes because they don't want to actually say in front of other people. Many was the European aquaculture producers, organized by Courtney Huff in those days, and they would have an app where farmers or people that were members of their association could input their data in terms of growth rate, performance, and then from that they would get a result saying how their data compares with the average. You know, but I thought that was a really good idea. That you know, the hard part, like Dom says, is people to share. But if you have a one-way street where people could actually analyze, look at their data, but from using your model, then it would be so useful.
Okay, great.
Sorry,
I will just
that was just a point.
No, it was okay. I wanted to add, but it relates to the next question as well. Sometimes that the feed millers, or we want to do a trial in commercial setup, right, with the farmer, and we don't actually want farmers to lose any money or profit from the trial, right? But as Dominique said, we needed to have a negative control, right? How can we avoid that thing, right? That is kind of critical. We can have a negative control. We can avoid a negative control, but we can have a control which is reduce spec plus something else that we are testing. That could be a possibility. That was kind of my comment on that. But the questions related to that are like feed millers, for example, want to test their feed, right? Or to test an additive, for example, to apply in their feed. What would be the best option for them, right? A growth trial, a digestibility trial, or both, or a dose response trial, something like that. And I want to hear, like, I think from audience as well, they want to hear opinions on that. So Dom, can you start on that, or Dominic?
Okay, yeah. When you want to test a feed additive, for me, I like this kind of progressive approach. You start with a lab studies or a small scale study where you test your feed additive under control conditions with the proper thing. So if it's a disease resistance or an additive that you think improve disease resistance, you need to do a proper growth and challenge trial. You need to challenge your animal with the proper disease you think is important, and then look at their response. You need a proper protocol under control conditions with good number of replicates, not huge number of replicates, right? 3, 4, 5, 6 number of replicates that you can accommodate within this graded level so you can understand the response. Then you can go to a pilot stage where you go to R&D facilities or a farm that you know has several things, and then you test a limited number of treatments with appropriate number of replicates also, and that number can be very high. And then you can go to a farm and test this. The problem in the farm and even the pilot scale, the performance is so highly variable, and the improvements you can expect to gain is so small that you need huge number of replicates. So comparing pond A versus pond B, or having 2 ponds on one side and 2 ponds the other side, or something like this, is not going to cut it for the type of gain that we expect. If we were in 1970s where we didn't know how to formulate feed, well, it's easy to show to formulate a good feed and a bad feed, right? But today the improvement is 5% if you at best, 10% if you're really lucky. So in order to do this, you need 20, 10, 20, 30, even 60 replicates in order to be able to detect that type of difference given the variability in the field. And so I don't know any other way than to go on a large scale effort, make a feed with the additive, without the additive, distribute it to many farms, and then collect the data from the farms and then look at this. That's where you need a system. That's why you need a software, a platform, or some type of common system to collect the data in order to get the power that you need. If not, I personally, I think there's lots of cherry picking. You just pick up, oh, that farm, it didn't work, right? And this farm, it works. So therefore, right, we're only going to pick the farms that work because we know our additive work, right? And you're kind of cherry picking, and it's called cafeteria style research. You pick up the results you want and you present what you want. Well, we need to go past this, right? So we need to go further than this and really assess the efficiency. And the only way I can see it is collect as much data from farm as possible.
Right. Dr. Tacon?
No, Dom is exactly right. I mean, I couldn't agree more. But also, it's for example, when we look at shrimp farming, again, there are many products on the market, many claims, but very few studies to really support these claims that have been independently run. But for the farmer, because survival at the end of the day is whether I make money or not, obviously, it's a way of hooking the farmer onto the product. But really, we really do need to have proper trials, independent third-party trials to validate a product.
Right. And what kind of
often
data? Sorry,
effect,
go ahead.
Sorry. Often maybe the effect is kind of a placebo effect, right? Also because the feed additive company or whatever is going to come and it's going to offer support, right? Additional support, or the feed company will go there and you'll take good care of your clients and say, oh yeah, your water quality is, you should take care of this. You should look at this equipment. You should look and do this. So you're actually interfering, helping your farmer get better survival, but it may have nothing to do with your product. It's just the care that you're bringing, the tender, loving care you're bringing to your clients, right? At that specific time. So
no, that's right. I mean, especially with an animal like shrimp, where so much of it also depends on density, water management, the time of day that you're feeding, and the oxygen level in the water, and so all the. But like Dom is right, but we have to input all this data and analyze it so that every season we learn and we move forward. The reality for the feed company is that every day the price of these ingredients are increasing, but the price of the shrimp, for example, are not. So it means that every year we have to make our feeds better and reduce feed costs per kilo of production, for example, and so, but we're only going to be able to do this by analyzing our data.
But this is a very dynamic process, right? Sorry. The research and then inclusion of data into the software or program has to be a very dynamic process because genetics are changing, industry is changing, feed manufacturing conditions are changing, machines are changing, right? So I think this has to be a very dynamic process. But the next question is which parameters? We'll come to data after this question as well. That there's a very important question on data integration when we test the additives. But which parameters should we look into, right? Sometimes we look at the for example, availability, efficacy of a toxin binder, for example. But we are looking at the growth or FCR. Does it make sense or not, right? Those are which parameters should we look into which we are testing a particular additive? That is a critical question to find efficacy or of any product or any additive. Which parameters we should choose, right? It's just not the growth and FCR. Sometimes we do growth and FCR continuously. Oh, it doesn't work, right? For example, did study and there was no difference in growth and FCR, but when you looked at differently to the data, right, we looked at a multivariate analysis of how different parameters are integrating together, correlating the other key variables. What you have seen that not necessarily growth and FCR, but it was driving the nutrient retention efficiencies. So what should we look at, right, for a specific kind of additives? If you have some opinion or some directions to the audience, right? This time Albert will take it, or Dominic?
No, I was trying to write some notes. No, one of the big differences between researchers and the larger feed companies is that when they do a trial, when they test a new ingredient or they test a new additive, they like to, okay, do the growth trial to see, or the disease challenge test, but also take the animals to market size and look at quality criteria, look at shelf life, look at the whole things. And this for the average researcher is very expensive to do, but that's why, again, most of the larger companies have R&D facilities to do, laboratory-based studies, but also doing studies to market size, and then the whole economics and 9 yards. Sorry, that was just a point.
Sorry. So sorry. You can jump in anytime. Dominic, please. Any comments on that?
Yeah, the growth in FCR is key, of course, right? That's what you're selling. You're selling biomass and you're buying feed. You're spending money on feed, so large part, it's important. How fast you're reaching, that's really important. But yeah, the quality of the product is important. Sometimes the weight distribution is very important, right? You don't get the same price for a small shrimp versus a big shrimp. In the Philippines, for example, milkfish, there's a medium size, right, that reached the best price. If the fish is too large, you get a lower price. If the fish is too small, as it was too early, so you get a lower price, right? So knowing the weight distribution of this, and very few farmers have this handle of this weight, so I feel they get cheated, or they don't harvest the fish at the right time, where they have the right price for their crops. So if they had a better idea of the weight distribution, we could dynamically estimate the value of this, and then the farmers may not get cheated also from the buyer. They should say, well, there was X number of medium fish and Y number of large fish, so therefore here's your number, your amount. So yes, the quality, the weight distribution, the sustainability also becomes important, right? So how it was produced, right? The story of the product becomes important, and the data tracing, the traceability is key to this. So if you can demonstrate that you did a good job, that you raise your animal properly, you respect the rule, well, you have better chance of getting a good value for your product and developing a good customer base and a good price, sustained price for your product, than if you just shoot the breeze and just Hail Mary production. You just say, well, whatever happens, right? And I'm gonna grow them very fast, and I don't care how I get it. So it's all part of the same continuum. Yes, not just growth and feed efficiency or feed conversion is important for sure.
So the final question in this segment is, say, for feed additive research, right? Can we use the tools that you mentioned to assess the efficacy of any feed additive? That's, I think, to Dominic, probably, yes.
Oh, absolutely. I mean, you're a feed additive supplier. You sell to feed mill, right? And these additives are used in feed to be fed to the fish. Like Albert mentioned, what matters in the end is the performance on the farm of your feed additive. How do you link this? Unless you do your own research with your own research center and you test everything yourself, which is very costly and it takes a lot of time and lots to replicate. And you cannot replicate what's happening on the farm. On the dozens or hundreds of farms, your additive is going to be used. So you need data. You need somebody to link you up with the farm data, right? And the feed manufacturing data, and then your feed additives. So I don't know any other way to do it, effectively, unless you have to invest in a huge amount of resource to set up your own R&D and your own follow-up and etc. So yes, having a system, that's one of the reasons that we're developing Aqua up in order to do that. So that's why, as an academic researcher, I realized this many years ago, working in Indonesia, with, collaborating with Jaffa Feed for many years. Says, well, yeah, we're trying things, but the guys in the field are saying something is happening, different is happening. How do we know? Well, we need to collect the data from the farm in order to know, right? And how do we know what feed was used and what was in the feed and at that time, etc. So you need to cross-reference everything together, right? It's not just the feed additive. The feed changes also, like Albert mentioned. The feed change every year, every week. The feed change formulation, right? Because the price of ingredient, availability of ingredient change. You have to take this into account. It's not just your additive that is acting up. It may be, right, mycotoxins or anti-nutritional factor or level of digestible nutrients that just change overnight. So it's important to keep track of everything, and you need a system to do that.
We are getting a lot of questions from a lot of audiences. I will get into that. There's one question to Albert, who has a lot of experience in research as well, in both commercial and research center setup as well as academic setup. Just a general overview, right, of the aspects, right, where a research can go wrong, right? This is very important for I think for the audience to understand. This is please go ahead, take the floor.
A general observation for sure.
Very general, yes.
That if the industry is using cages for the production method, then obviously it's much better when we can do our R&D in cages. If the production is in ponds at a certain density, we really have to do the R&D in ponds if we want to apply it to a pond situation. Sure, we can use tanks for certain things. I mean, a good example, I mean, I think Dom also mentioned it, and that is that many years ago, I saw results of from a feed company from selling the same feed to 156 different farmers. And they got 156 different results, and they plotted the data, and they had a normal curve. Some farms did very, very well with the same feed, other farms didn't. I mean, the important thing is that we have to analyze the data. If you don't analyze the data, we're never going to move. But very few companies do that. Like Dom says, I mean, every week formulation changes with exchange rates and prices. But we have to. There's value in that data. Sorry, that was just a general comment. Again, another area is, again, Dom knows this much more than me. Very few companies formulate their feeds on a digestible and essential amino acid basis. But it's something that's it's not difficult to do. If you set up your own facility and laboratory where you can measure the digestibility of your ingredients. And I think we could have a whole webinar just on digestibility and the different methods. It's very, very important. Because at the moment we're doing like this. It's a guesstimate for many companies.
I will just repeat it.
But it's so important. It's so important.
Right. Dominic, any opinion?
Relate to this, yeah. So digestibility is, yeah, we should be formulated on a digestible basis, but the reliability of estimates of digestibility are not that good. And actually, digestibility, I say now, is a measure of disappearance. It was in the feed, it's not in the feces, so therefore it was used by the animal. It may not be, right? There might be leaching, there may be absorbed under a formula is not used. So we have recent results where, for example, feather meal, we're able to measure high digestibility, but the bioavailability is not there. It's 20, 30% lower than expected. Heat process, certain heat process, excessive heat process or heat damage protein react the same way. And the nutrient, like the heat damage, should not create that big of a difference. If damaged amino acids, who cares, right? It's gone, but actually it's interfering with the digestibility and bioavailability of all the amino acids around it. And that's important. So we need to do more work to actually develop better technique to estimate digestibility. And there's been lots of work, but the work has been a lot of what we call in French the church war of the churches, word of the tower bell, right? The bell tower or stuff like that. Oh, my system is better than yours, right? 12 and better than the French, and the French the stripping is this and that, and everybody's things without kind of looking for the truth, without looking for useful, how this information is useful or not. There's been, when I was a student, that was the whole thing. Digestibility was which one of the system is the best and which one gives you this, and this guy doesn't know what he's talking about, and the other guy is full of it and whatever. So it was kind of not very useful to make the field progress. So now we need to be more systematic and rational about it.
Anything to add, Albert, to this?
Yeah, no, and that's right. And And then you have the feed, some feed companies already doing it, but keeping very quiet. And what we have to do is that we have to increase the, increase the dialogue and try and come up with tools that the other partners in industry can use.
So
And that's
I would
where
like to go ahead.
that's where the academic can play a role, right? You may not be in the know with the feed companies, but you can buy the same ingredients and you can do digestibility trial and build your career and publish paper and have great contribution in the industry by doing something accessible to all, right? And it's not rocket science, and it's useful work. It's as good as doing PCR on this and looking at the gene expression and right in all of these different things that, yeah, it looks very good, but in the end, how do you use it? How does a feed manufacturer use gene expression pattern, right? So whereas digestibility, nutrient retention, and all this ingredient quality is something that you need every day of your life as a feed manufacturer.
No, and that's right. And if you can demonstrate to the feed manufacturer that if you formulate on a digestible nutrient basis, you can actually save money.
Obviously,
that's the bottom line. And so, but
yeah,
we have to convince people to go on that route.
it's coming. It's coming. It's changing. I've seen changes in my 30 years career now, so I've seen a big change.
In Vietnam, you have to put like a digestible nutrient label on the bag, on the feed bag. So it is regulations has to be there as well for feed millers to practice that. So there are some very interesting questions from audience as well and comments. I will read some of I will read from Sabrina. Simi said thank you, and there are some questions. I think they're from Lima, Peru. Carlos Davia. I think she is with Vita Pro. And there is an interesting question and comments as well from Maria Nicolini. She said that this is a great presentation. Many thanks for your insights on data within the aquaculture industry. Digital farm management tools have bloomed in the past years, right? So everyone's like an insect meal. Now we have about 400 producers globally. So this kind of tools, also a lot of investment, a lot of people are jumping into, right? So I think both of you can touch this question as well. What are the main reasons, in your opinion, that they have not become widely used worldwide by now, right? Albert wants to go, or
what's this? You're talking about insect?
No. This type of tools, the data management tools, right? Why they are not becoming widely used, right? This has been around probably 4, 5, 6, 7 years now. This kind of tools, and if you go with Akimasu, there were some other softwares as well at the time, almost 10 years ago. So why they are not becoming like mainstream, I would say, if they're so useful, Albert?
I'm sure Dom can reply to that. I mean, all I can say is I'm sure that those larger farms, those corporate farms, are already doing it because they know that the bottom line is we have to analyze our data. We have to learn from every cycle of production.
Yeah,
Dominic.
The softwares have been around for a long time. Farm control initially by EWAS, and then BOT, and then Fishtalk, Mercatus, Aquanetics. There's several of them. Farm control. Yeah, there are several. There are things. Some of them are affordable. Some are extremely expensive. Some are very complicated to use and requires months and things. And some are a lot easier to use. We saw a need in the market that they say, well, we need something affordable, something easy to use, and something that where the data is analyzed properly, and we have proper growth model and proper feed requirement model and proper estimates of waste output, etc. Which things. But in the end, why I think it's not adopted is just gathering data is useful, but everybody's doing it in their own. So you're not really adding a value. Say, I'm already collecting data, right? So why would I need you? You need to offer value. It's the same thing Google, right? If Google's just, his job would say, well, let me collect your information about your birth date and your sex and what you buy, something, say, well, okay, go away. I can do this myself, right? But Google gives you a value, right? You search information, you get information, right? You have all different tools. You want to find your way. Oh, there's a map. There's a right. You don't need a GPS anymore. It's all built in your thing. They give you value, and in exchange, you share your data. So this is the mindset that companies have to have. You have to give something in order to get something. In order to get following, you have to give something, and that's what we realize as a company. Says, well, we need to give more, provide feed recommendations, or right, or some tool estimates oxygen requirements, waste output, ammonia production, and all this. And that's what we're building: this value of feed ingredients, feed formulation tools, compilation of feed ingredients, quality, etc. So different users will be interested in different things. We have to give back in order to get the information and get the adoption.
We have 8 minutes. We will take 4 questions. There's 2 questions from Pakistan, Mr. Hafiz Akram. It's kind of about collecting quality data, right? So he's asking about how much should be minimum population. I think it should be treatments or replicates one should require, and how much time duration. Albert already touched that partly about the we should grow market size. He also asked how much % difference in real data versus software predicted model data, right? And do software also predict disease prevalence and extent of % of mortality? So kind of natural or, okay, who wants to go?
Dom, you're the expert.
Dominic, Dominic is the second part, and then first part we go.
Yes, the model and the data go together. You develop a prediction you gather the data, you develop a model, you develop a prediction using your model, and then you see whether it corresponds to reality when you collect more data, etc. I like to take the analogies that when you're walking, your brain makes a projection. The floor is there. It projects your foot. It tells to your leg to extend your leg, extend your leg, and your foot is going to hit the floor. But you only know when you hit the floor when the bottom of your foot hit the floor and tells you hit the floor. So that's the same thing. The data that you collect is telling you whether the model prediction. So it needs to be dynamic, like you mentioned, Kabir. It has to be a dynamic prediction. And yes, we can predict mortality or the consequence of mortality that's changed. For example, we're working on what we call an Asian-based model, individual-based model that predicts the effect of change in water quality. As you drop oxygen level, right, there's a certain critical level at which the shrimp are dying. Same thing for ammonia. So you can make a prediction that says, well, if my ammonia exceeds 10 milligrams or something, yeah, I know the shrimp is going to start to die like crazy. So you can make these predictions, but then you have to anchor it in reality and see whether it's happening or not, or look back and say, well, when I have water quality data, then you have to reference it versus the real data, right? And then identify when there was an effect or not. And then you can use this knowledge to say, oh yeah, when 10 milligram, we reach 10 milligram of ammonia N at this pH or something, right? Well, then we see mortality occurring. So you can that's how you transform data into information and information into knowledge. You know, X level of ammonia will be a problem. X level of dissolved oxygen will be a problem, results in things. So that's how you build this knowledge, by integrating, taking observation and transforming it into predictions and understanding. So the model works exactly the same way.
Okay. Albert, any? Yes, go ahead.
Just to add to that, most of the companies that have been developing models have been, within the Americas, within Europe. One of the differences with a lot of Asian aquaculture is that it's small scale, and so if we want to encompass that, one approach I like very much was an approach used by farming associations like ABCC, the Associação Brasileira de Criadores de Camarão of Brazil. And what they did is, what they used to do, I don't know if they do anymore, is that every year they would do a diagnostic of the industry, of the performance of the different feed companies, the analysis of the different feeds, how well they stacked up to what the label says. But it's a very powerful tool, and in Indonesia, in Asia, farming associations are quite strong, and so that could be another way, Dom, to try and get them involved into actually getting individual farmers to analyze their data and put that into a central database. Sorry, it was just an idea, I thought.
Yeah, I mean, that's a good idea. When I was a student, many of my classmates actually went to work for we call circle of producer, of dairy producer. So 50 dairy producer would get together and all pitch in to pay the salary of an agronomist, economist or something. And the person would do their taxes and would do the analysis and recommendation. And they would pay something like between $5,000 to $10,000 per year. And they would have a full-time person working for them, right, on issues interesting. So this is a system.
Yeah.
You have an expert working for you, able to use the software, able to support you, able to do this, right? And you don't have to spend a fortune supporting them because you're an association, you're a group of people, each one you paying part of a salary, right? That's how that works. That's one system that could work really well.
So we have just 5 minutes, but there's some questions and comments. I would just take 30 seconds to read from Ms. Vu Mai and Can, I guess from Vietnam. So its model your model helps farmers to real-time management of their systems. So that's but she wanted to know more. Probably we can talk about that later. There's another question from Dr. Rossi from Kentucky State University about digestibility trial, the rationale behind 70-30. I think we can talk about that later or in future. Another question was, to what extent does this data problem apply to other feed industries, right? Are they already doing it? Can you take 30 seconds for it?
Oh, I mean, I came from a dairy background and swine, I trained in swine nutrition, also swine production, and software were everything. So, I mean, dairy farmer always relied to a model to predict the feed requirements of the dairy cow and look at the milk production curve and look at the genetics and all this. It's all model driven. So that's my example. That's been my beacon of information. So yes, we can learn from other industry. What other industry don't understand is that we have a very complicated system. We have partial harvest, right? The chicken farmers or dairy farmers, they harvest milk every day. It's not just like, oh, one day I'm going to harvest milk and the other day I'm not going to do it, and then I'm going to stock more stuff into my barn. No, it's right thing. So we have a complicated environment. So we need a flexible system, and we need a company or system that understand the culture. And yes, the model can be used in real time. You can predict oxygen requirements of fish or shrimp. You can predict ammonia production. You can predict CO2 production. And you can say, well, this X volume in my tank and X exchange rate and etc. You can make prediction about the change in water quality using models, which right is going to impact you. Yes, it's complicated in some case, but many things are complicated and they're approached in small bites.
So we came to almost the last part and the last question, I think, and the biggest issue that we have, sustainability, right? There's a question from Patricia Sugui about what is sustainability index. Both of you can define that. And are you working on carbon footprint of feed ingredients? And congratulations for the presentation. But I'll summarize all the sustainability issue. I have 3 questions on the sustainability issue. How can we ensure that the decision output is accurate, right? It can vary by environmental, by species. Obviously, you consider species, by disease outbreaks, by rainfall, by cold temperature, right? Sudden cold temperature or sudden heat stress. Number 1. Number 2, are these tools that we can find in the market, are they comprehensive and available, affordable for the normal regular user? What about the small marginal farmers or small feed millers, right? They don't have that capacity to do research. These tools can be very useful for them because they cannot afford to build research facility, or they are higher capable researcher. Third question is, could there be a better solution, right? As Patricia said, ecological footprint or including carbon footprint, you're already there. And how can we improve these tools to be inclusive, to be more inclusive and covering more stakeholders? We just have feed millers and farmers now, more stakeholders, right? Market value in the value chain, raw material suppliers, you added additive suppliers. So this is like all together, but to both of you, you can take, I guess, 1 minute each. I would say 50 seconds each. Okay, thank you. Albert wants to go. Okay.
Oh, no, I mean, you had to calculate. You want me to? I'll let Albert finish. So cap up the evening nicely.
Awesome.
I mean, you want to calculate carbon footprint of like associated with a fish production, right? A salmon, or right, to calculate a fish in, fish out ratio index. How do you do it? Well, you look at your production, your feed consumption, but then you say, well, I use the feed from company X, right? And say, then you call the company, how much fish meal did you use in my feed? How much fish oil did you use in my feed? Can I get a certificate because I need to report to BAP or ASC to say that you use this level of fish meal and did you use certified fish meal, etc., right? So you always have to interact. What if, right, you can have what we call seamless, non-interfering collaboration? The company uploads this information. You don't need to see it. You don't need a certificate. As long as the company guarantees it or something, and there's an auditor, and then you go, your system with the data is matched with that information, and it calculates objectively a FIFO, right? So you don't have to do this. So we can do things better, more robust, more reliably by having things integrated with non-interfering collaboration. Same thing for carbon footprint, right? How do you know this, right? What do you call the soy producer, and you call the fish meal producer, and you call the guy in this? So you end up spending your life on chasing information, where this information could simply be uploaded and be used by all, right? So this is the goal of what we're building, is make life of the farmers, life of the certification bodies, the lives of feed manufacturer easier.
Albert?
My 2 cents worth is, I mean, most farmers do their activity because they obviously want it to be economically sustainable. So it's obviously which lens we use to look at sustainability, whether it's environmental sustainability, social sustainability. You know, and these are all very much developed country market requirements, where we're asking, you know, that we want to know where our food comes from and how it's produced and at what cost to the environment or society. I don't disagree with it, but I just don't want us to forget the fact that we have the other consumer in the world, which are the ones where we need to produce food, but obviously it has to be green and clean and above all safe. And so I think feed safety is an important criteria. It's normally not on that radar screen at the moment, but sustainability, it's very much a loose term, and it all depends on how we define it.
Thank you, Albert. I think we are almost at the end of our session. I will ask Annie to come back and join us. So thank you both, Dr. Dominque Bureau and Dr. Albert Tacon, to be with us today. I will just, before Annie wraps up, next session will be in August 20. It will be in memory of Dr. Senna De Silva, who produced a lot of scientists as well, and played a key role, especially in Asia, to develop aquaculture, starting from reservoir aquaculture in Sri Lanka, and then I think played a major role in the development of aquaculture and fish farming in Asia. So our next session will be August 20. Mark your calendar, and it will be in memory of Dr. Senna De Silva. Annie can close and then say something, right, about what we will do.
So for the question left in the question box, if we didn't answer to a question, so we're going to be answering those questions by email for sure. You are also welcome to leave other questions via the link that you received by email. So you can just reply to that email. So we're going to receive the question as well there, and so we can share and respond to you after the session. As a reminder, we left a copy of the presentation in the document file in your dashboard, so you are welcome to download it if you want to. And we're also going to be sending a copy of the video of tonight to all registrants, so you can check your inbox for that.
Thank you, Annie, and thank you again, Dr. Dominque Bureau and Dr. Albert Tacon. Thank you so much for making this as a successful event. Thank you so much. Thank you all. Okay, have a good night. and
Take care.
a good
Bye-bye.
day from somewhere else. Okay.
Merci,
Bye-bye.
Annie. Au revoir.
Merci.
Yeah.
Thank
Ciao.
you.
Ciao.
Ciao.